Let's see. Ignore that. Okay, everybody can see and hear okay? Glad to be here doing this finally. I've been working on my slides for the last day or so during sessions, and I'm ready to get over with. It looks like maybe that doesn't show the whole slide, but this one does. So, yesterday, my friend and fellow Shmoo informed me that my hotel room directly overlooks a topless swimming pool. I don't know if you guys all have the same luxury, but that reminded me that I had to work on my slides, so I went right up to my room, got out my video camera so that I could get some good shots for the, for the slides. Unfortunately, what I saw was a whole bunch of pasty white geeks. I know you guys were out there by the pool. That's all I got out of it. So. Anyway, you guys will want to stay to the end. This isn't like other presentations. This one's going to be really good. I have cool graphics, and I have a prize for the winner at the end. So if you're so inclined to leave, just put your head down and take a nap where you are and stick it out. It'll be worth it. And then the other thing I would say is I'm not going to probably take questions deliberately at the end. I prefer that you just jump in. You don't even have to raise your hands. Just yell stuff out at me, and I'll run it through my entropy gathering daemon and give you a response. So the deal here is email has turned out to be the most popular thing on the internet. You know, that's not just a revelation to me. I think everybody has realized that by now. It's except for porn, yeah. Porn via email is the, yeah. So there would be no porn without an email. So the deal is, if I were going to go and design an application and try and make it real damn insecure, probably what I'd end up with is something like email. I think you guys have probably all given up Telnet by now. Email is no more secure than Telnet. Probably using the same passwords for email as used for SSH and all the elite new crypto protocols that you're using. So my contention is that if email isn't secure, nothing else can be secure, right? Everything that a company, that an organization, enterprise is doing is going through email. You just can't stop that. Your financials are going through, all your contract negotiation, hiring, firing decisions, all that stuff is going through email. So you may know that, and that's why you're here, but the point being, if you can't secure email, there's really no point even starting on anything else. That's what I think. So I'm still working on securing email. These are some of the obvious issues. Operational discussions, what is the company going to be doing? What is the enterprise going to be doing? Hiring and firing decisions, all this kind of stuff. I mean, I don't have to tell you, you don't want this out in the open, but using email introduces the high probability that it can happen. Security breaches are common. This is, just stats I pulled down off the net. I know you guys know all this from all the other sessions, but the basic idea is that, there are adversaries, there are people hacking your systems, there are people trying to get it, if only for fun. And that's why you're here at Black Hat. So I don't know what just happened there. Okay, corporate espionage. This is a serious consideration for the enterprise, and this is kind of the level we're trying to operate on. Is say, hey, how much would you pay to read your competitor's email? Might not be much. Ethics aside, because you have to assume that. How much would your boss pay to read your competitor's email? That's one way I like to look at it. And then, of course, to consider that that's probably about how much your competitors would pay to read your email. I think that that's a really good place to start. I think it's a good metric to decide how much money you're going to spend on security, because a lot of companies are left wondering. A lot of organizations don't know, how much do we spend on security? Where do we start? And this is a good exercise to go through. Another application, or another aspect of threat that I like to point out that's actually turned out, not a lot of people consider this, but it's one of the biggest deals, is what we call the discovery dilemma. This is where a corporation gets sued for anything by anybody. In the process of getting sued, they get the court to issue an order that allows them to discover all your email. So your entire organization's email gets seized, and read by lawyers for the bad guys. These lawyers go through and find all the more interesting stuff to sue you for. This is going on constantly. This is probably the absolute biggest threat to corporations using email, which is all of them. So these are just some examples. 33 million email messages were seized in discovery from American Home Products. I don't even know who they are. $3.7 billion paid in damages. So, of course, I'm sure that's the worst one we know of so far. This is not a statistic that people are actively trying to collect yet, so we don't even know what we're missing. So that should scare you. This is an example of a typical email message in case you're wondering what we're talking about today. Hi, Bob. Here's that link I told you about at lunch. And, you know, if you look at your own email, you'll probably see that, you know, this is just a lightweight soft porn situation here, but the basic idea is that email people are sending back and forth in corporations is highly implicating, even if you're just innocent. So consider that. And passwords, people just, I mean, as you know, mail protocols send your passwords in the clear, but you know, people just email passwords around to stuff because they don't, you know, most people don't care about security. I don't know how you're going to stop all that. Basic vulnerabilities of a message like that are that it's being sent in the clear over the network, probably within the corporation, probably all over the internet. If you look at, you know, average hop count of a trace route, you'll see that, you know, probably every email message is going through a dozen routers, at least as many switches, and you know, you can't control where that's going. Every single one of those people has the people who have access to any point along that way have pretty easy way to go look at your intercept your email. So clear text passwords, this is one of the worst things. All the passwords for all the mail protocols are largely clear or easily crackable. And what that means is if I can get your email password, which is in the clear, then I can probably use it to SSH. I can probably use it to get onto your, you know, Windows NT shares and all this other stuff, because who wants to keep track of multiple passwords? And if it's not yours, then it's your coworker. It's just rampant. Password collisions with other systems, that's what I was just talking about. If people are using Yahoo or Hotmail and they have passwords on that, if I can get that, I can get probably their corporate email too. Net traffic crosses dozens of routers and switches, I covered that. No data integrity, obviously I can easily, you know, or the contents of email messages isn't, you know, signed or hashed or anything, so you don't know if it's real, you don't know if it's coming from the person it claims to be. It's so easy to forge. I can forge messages from anybody. You guys know all this by now. Okay, so I wanted to go over some of the history of email security, because the thing about it is different attempts have been made to secure email. You're probably familiar with some of them. PEM, you're probably not. That was just one of the early ones that tried to become a standard that didn't really get anywhere, but it did influence later standards. Secure email services are out there. You probably run into some of these. Hushmail may be the best known of them. Trying to think of what to say about Hushmail. Those guys started out with really good intentions. They basically built a service that works like an encrypting proxy. So what happens is you send email to Hushmail from anywhere, from Hotmail. It gets encrypted to the user's key, gets stored on disk that way, and this prevents, you know, a certain gamut of passive attacks. And what happens is when you're sending mail, you go use their web, it's just webmail, Hushmail is, and you go to their webmail interface and you create messages. And if you send to other Hushmail users, then everything is more or less encrypted between users on the system. Hushmail, of course, is a trusted third party. They try to set it up so they don't have to be, but really they are. And so the deal is, you know, obviously you have to trust them, but that's better than nothing, right? I'm for that. I initially, you know, one of the things I do in my spare time is find anybody who's working on secure email systems and go bug them. And what I bug them about is trying to adopt standards, and they've been trying to do that. They've been trying to implement PGP, but in the process, I think they made their system a real big pain in the ass to use, so they're losing users. It's really sad. But anyway, Lockmail is another one that sort of works the same way. MailVault does the same sort of thing, trying to use PGP. But all these guys, what they're trying to do is simplify the use of secured email, and we're going to get into the compromises that they're making a little later. Yahoo has a little checkbox you can click that says, I want to use secure login. when you're using Yahoo Mail. You click that checkbox, you put in your username, password, you click login, and what do you know? It uses SSL to encrypt your login credentials. That's great, but then it drops you into clear mode to send all your mail back and forth. So I don't know what the point of that is, but they can tell, they can say, hey, we offer secure mail, so whatever. Be really wary of those guys. All those systems, they're just, a lot of people in the business of any kind of security, and this in particular, are just trying to check a box that says, hey, we're secure. They just want to sound like they're secure. Proprietary email systems. To be honest, these are the ones that scare me the most. And the deal here is you've got corporations who wake up and say, wow, we could make a lot of money selling secure email. And this is true of any security product. And they generally go and implement some crypto scheme, which is maybe secure, maybe not. From our experience over the years, we found that pretty much all of them are not. But I can't say for sure on any given day about any given one of them. You might be better off than nothing. All this stuff, by the way, that I'm slagging is better than just plain text email, which most people are doing now. So I'll give them credit for that. Zixit, probably the one that scares me the most. Really big company, headed up by former CEO of Blockbuster. Raised a bunch of money, built a big data center, put an armed guard in front, and said, look, we have secure computers. And they created this key escrow system that they were going to sell to everybody, where every user gets a key. They keep all the keys on their server, and it encrypts mail between them. So I guess that's good. But they have modified it a little bit, and it's actually, I have to say, it's real easy to use. It's real slick. They have time stamping service. They have return receipts that are all signed. And they are going after law firms. That's their big deal right now. They are getting law firms nationwide one at a time to switch over this. You load the software and it runs with Outlook, and it's probably it's better than nothing. The thing that bugs me about them is that they're not standards based, and I'll get into the reasons why that bugs me in a minute. I don't have anything particularly new to say about Lotus. If you're using Lotus Notes, then what you've done is bound yourself to an app that you can never migrate off of, basically. That's the same for Exchange. There are new exploits for Exchange on a regular basis. I think one of the sessions earlier this morning released a couple brand new exploits for Exchange. And again, the big problem with Exchange is that it's binding you to, if you're not aware, they have this calendaring system, which is real slick, built into Outlook and Exchange. And that ties into the email. So I think that's a good idea. You need all those things. Sadly, they're not standards based, and once you buy into that, there's just no migration path to ever go to anything else that's more secure or different anyway. So if you're using Exchange, which unfortunately most people are, then some of the other things I'm talking about will still apply to you. But it's a risk to buy into something that you can never get off of. Omniva I wanted to talk about, because what they did is they created a secured email service / client that you load that works with Outlook. And the thing that they're specifically trying to do at Omniva, formerly called Disappearing Ink, is make email that is secure against the discovery problem I talked about earlier. So what they do is they have every message has a unique key. They all adhere to a policy where the keys are expired on a regular basis. And so what happens is corporate email only sticks around for 30 days or whatever your policy is. So worst case scenario is all your mail is discovered in some lawsuit, and they can only find the last 30 days of email. And that's exceptional choice to make for companies who want to limit their liability. I sort of like Omniva, despite the fact that they're not doing standards. Unfortunately, I don't think the existing mail standards would do a good job of what they're trying to do. I would like to see their system, or at least their protocol, standardized or tacked onto PGP or something, but that's all in the future. Anyway, something to consider. For pretty much any corporation, I would be willing to bet going and buying service from them would be better than being a sitting duck and just waiting to get sued, because it's going to be a lot cheaper. Email security standards. This is sort of the thing that interests me the most, and what I have the background in and what I work on. My goal in life is to raise that bar of email security just a little bit at a time. And right now, it's pretty, pretty easy pickings because all the email is insecure. So PGP is probably what you guys have heard of the most. PGP is about a decade old now, got a lot of momentum over the last maybe 5 years when a company also called PGP Incorporated made some applications. Phil Zimmerman, who started that, got thrown in jail and all these sorts of things for exporting strong crypto, and then he also had RSA come after him for his plagiarism of their algorithm. All that's ancient history now, but the point being, PGP has really dominated the hearts and minds of people working on secure email. I'm a big fan of PGP. It has since, one of the great things that happened before PGP, or when PGP got bought by NetAss, and then they ended up canning the product this year. But before that happened, a few bright people at PGP managed to create the open PGP standard. So we now have all the protocols that PGP uses in a standard in the ITF, and it's more or less actively maintained standard, and it's pretty good. It does a good job of creating encryption for email, the signing protocol, and a fairly innovative trust management system. And this is what I like about PGP, is that it is very flexible. You have these basic constructs for encrypting a message, signing a message, and you can use those things. You can use the signatures to manage trust on keys, which is a really, really big deal if you're trying to do anything really secure. Sadly, I looked through my inbox just to give you guys a metric, and you guys can probably guess that I'm a real email junkie, email security junkie. I have something like 763 messages in my inbox. This is after filtering out all the spam, all the stuff I've dealt with. These are like actual messages from people I know that I got to respond to. So it's a lot of mail. But I looked through there, 11 of them are signed, 14 of them are signed and encrypted. So it's like 2%. And I'm probably an order of magnitude or two beyond your average user as far as encrypted email usage, right? That's pretty dismal. In our experience using PGP and compatible tools, in the SHMU group in particular, we have about 30 severe security junkies. I mean, we're all people who just can't help ourselves. We eat, breathe, and sleep security junk. And we all have PGP, and we all know how to use it, and we can't even keep it working between us, right? That's pretty sad. There's a lot of room for improvement in PGP, both the implementations that exist and the standard. SMIME, if you're not aware, is another email security standard that was originally spearheaded, I think, I'm not honestly sure, I can't remember where it was started. I think Netscape may have done it. Microsoft picked it up. What's that? RSA did it. Netscape implemented it early on into their mailer. Microsoft did as well. SMIME as a standard is pretty good. There are some problems, including what I would consider security issues with it, primarily with SMIME. The two main security issues are that the way it is, the way the standard is written and the way the implementations work, it's forced into a backwards compatibility mode, which means that I can get you to use 40-bit crypto anytime I want. So if you trust 40-bit keys, then that's fine. Again, I think SMIME will be way better than nothing, but it's something to consider. The other thing is that in SMIME, signatures are put outside of the encrypted body. So this has been talked about in some other sessions over the last couple of days, but what that means is you're basically creating a cryptographically secured surveillance system. Every message that you send to people is signed outside the encrypted message body, so the signature can be resolved by anyone. So whatever, it's something to consider.
One clarification.
Yeah.
I think the weaknesses you talked about are just in SMIME version 2.
That's something I've been trying to find out. I tried to confirm that, and I heard that they were there in 3. Yeah. Oh, I'm sorry. The question, what he stated is that what I've told you about the security problems with SMIME are only in SMIME 2, and there is a new version called SMIME 3. I don't know. What's that?
Does anyone implement?
We don't. Well, OpenSSL doesn't. I don't know about Microsoft. Netscape seems to be really dragging on their SMIME support. I honestly don't follow SMIME implementations as closely. One of the important things that I have learned from S-MIME, having used it previously, is that the implementations are really good about some things. They're opportunistic in the sense that when I send a message to 5 people, if I got keys for 3 of them, it'll figure out, oh, you got keys, and it'll encrypt to those 3, and the 2 that it doesn't, it'll send in the clear. You know, depending on your security model, you may or may not want to do that. It's something that's a real big pain in the ass with PGP implementations that I've seen, right? So that's something to consider that I think we should learn from the S-MIME implementations, is how to make that, and this is more for the developers in the future, but the idea is make email encryption opportunistic. You know, do it every chance you get. For the people who you have keys for, go ahead and encrypt to them. Even if you don't trust the keys, go ahead and encrypt to them. You know, add trust later if you get really scared. I like all that. That's not really happening in the tools today. S-MIME is also good about propagating keys, because what it does is every time you send a secure, a signed or encrypted message, it just tacks your key onto the end. Crappy for bandwidth, but it gets your keys out there. And this is one of the big problems we've had with PGP. If you're familiar at all with the PGP key exchange situation, it's like, well, it's real easy to get started. Any 2 of us can just fire up PGP, generate key pair. I can email you my key, whatever. That's, you know, that's all deliberate activity, though. In S-MIME, it sort of automates part of that. In PGP, what I do, and I'll probably stick with PGP for the rest of my talk, just because I think it's a little more flexible and I'm working on it more. But again, most of the things I'm talking about could apply to S-MIME if you were really perverted about it. PGP asks you to go ahead and sign the key that someone else has given you. So if I get a key from Alice, I don't know that it really came from her, right? This is what public key infrastructure is all about. If I get a key from Alice, I'm going to look at that and say, well, maybe it came from Alice. Maybe someone made it up and just sent it to me. So that's where the key signing comes in. In S-MIME or SSL, it's hierarchical, and so you get certificates from some trusted third party. PGP tries to make that trusted third party a little more flexible so that any of you can be a trusted third party. But what's happening is I'm going to try and talk to Alice, say, is this really your key? I'm going to read off a bunch of hex and all this complicated crap. She's going to say, yeah, that looks like my key, and then I sign it. And then from then on, I'm managing that trust of that key. So this has turned out to be a really big pain in the ass. People don't do it. I have one of the keys that gets, you know, signed by lots of other people, and you know, it's a real pain. And it's only because we're nerds that we go to parties and ask each other, what's your key fingerprint? And we sign each other's keys. I mean, that's uncool anywhere else. So the deal is we have to come up with something better. But I'm going to talk about that in a little more detail in a sec.
Do you know any good client that integrates PGP encryption?
There are, you know, I think that
What was the question?
the question is whether or not there's any good client that integrates PGP. There are some, you know, I'm mostly using Unix machines. You can see I have Mac OS X here, and it works good on Mac OS X. There are the Unix ones, Kmail does it really well. I think that there's a plugin for the other mailers on Linux that probably doesn't apply to a lot of you. On Windows, the PGP implementation works okay with Outlook. It's not great. I don't think I've seen one that's great. What I say is about the standards is that the main reason I want people to stick to the standards instead of trying to improve email security by making up their own system is that we have this user base of people who have only so much tolerance to try some email security system, right? And then they're going to give up. A lot of people have already done that with PGP. A lot of people have done that with S-MIME, and they're not excited about going out and trying the next new email security system. So I say that that factionalizes the secure email user base. I would rather have people who are going to make email security easier go and develop applications that take the standard and then pervert it in some way. Take PGP and throw out key signing, right? Because that's what they're going to do anyway. First thing they're going to do is throw out key signing. I have a slide on this somewhere if I could just find it. I don't know where it is, but we'll get to that, I guess. I'm getting ahead of myself. Basically, I dropped my laptop and all the slides got, you know, shuffled out of order, and I don't even. Yeah, I know you don't buy that. So And then the other thing about the standards is that they have been thought through. They have been thought through by real cryptographers and real cryptanalysts and real security experts. For better or worse, they're pretty good. PGP stands for pretty good privacy, and I think that still stands today. The deal with the standards is that they offer you a comprehensive security model. If I want to send secure email to Alice, I know how to do it. It may have been a big pain in the ass for me to learn. It may be hard to do it. But I can take PGP. I can do secure key exchange with her by calling her on the phone or whatever I need to do to trust the keys. I can go ahead and encrypt a message. I can sign it. She can get it. She can verify it. We can do all those things, as much trouble as it is. That's a good start. That's better than nothing. And for severe situations, you can secure your email like that. I know it doesn't work in daily life, but it's possible. And in the case of security implementations for email, I would rather see that those standards get, use a subset of it, dumb down PGP, just get people using it, and that way they're still using a standard, their keys are still valid, and in worst case scenario, when they start to get scared or something matters, they can ramp up and gradually over the years use it in a more secure fashion. That's a possibility that's really not being employed by people who are not using the standards. So, and then the last thing I would say about the standards is that strap-on interoperability is not feasible with crypto. What we do as engineers and a lot of other disciplines or in software development is say, oh, I can become compatible with that. All I got to do is insert one more layer of abstraction and I can translate. That's how we build software, right? It's just one more layer of abstraction. That can all be solved. That's not true with crypto because you have real serious security issues when just one little bit changes, right?
It's not necessarily security.
It could be security issues. All you got to do is have one guy implement the encryption algorithm slightly different than the other guy, and you can blow it for everybody. So the reason I say that is that it's got, security, it's a big pain in the ass. If you guys haven't figured this out already, you got to plan it from the start. It's really tough to strap on later, and that's a lot of what we're doing. And in the case of crypto systems, if I were going to go today and try and make SMIME work with PGP, that would be pretty much a lost cause. Nobody's ever going to try and do that. I can guarantee it. It's suicidal. Mythical encrypting proxy. So one of the first things, as I said before, that people try to do when they try to make secure email easier to use is throw out trust management for keys, right? Because that's the real problem, is from a perspective of ease of use. If I'm going to use public key encryption to secure email between people, I can do it completely transparently without doing any key management, right? All this PKI stuff, if you guys are into security over the last couple of years at like RSA and stuff, there used to be this big push for PKI. Everybody was going to get a certificate server and do a cert authority and run their own registration authority, and all their employees would be able to get certs, and we'd trust everything, and it would all be rosy. Absolutely none of that ever happened. I personally know of, almost no successful deployments. Yeah, go ahead.
I think the biggest problem is that people out in the world don't see why they need to encrypt an email without going to lunch. Why should they encrypt their?
Yeah. I don't think that the solution is going to be to change their minds, unfortunately. The rest of the world doesn't care enough about security. They just want to sit down at their computer and use it. As security architects, we need to be building these systems to be as opportunistic as possible and just make stuff as secure as possible by default. That may not be as secure as we'd want it, being paranoiacs, but it would be better than nothing and better than what we got today. So the idea is...
Where were you going with PKI a second ago?
Yeah, I'm sorry. The thing, what I was saying about PKI is that it has been very difficult and very expensive and largely a continual series of failures trying to get PKI deployments off the ground. Some of you may be in companies where you have it working. I talked to a guy at Microsoft who claims they have something like 60,000 employees with certs in their hands. And
Some non-employees?
And maybe some non-employees, and maybe some, and almost no usage of them, right? So maybe they'll change that over time. I hope that they do. I'm all for it, but it's been difficult. So one of the things that you see people come up with on a regular basis is what I call the mythical encrypting proxy. And the idea here is I just use email like normal, and something sits in the middle, whether it's on my machine or at my mail server or somewhere along the line. Something's going to intercept my email message, pick it up and say, oh, this is going to Alice, grab a key for Alice, encrypt it to that, send it to Alice. She's going to have something like that that's going to say, oh, here's encrypted mail. It decrypts it and hands it off to her. So it's completely transparent, right? This is something that I hear a lot when people are coming up with ways to encrypt email. And to be honest, it's, you know, it could work. It's never really been done. I don't know why. It's, you know, some scripting, really. But the deal is, you would end up with no trust management for the keys, really. You would end up with a system that, you know, just proxies encrypted messages and probably is going to start failing. What happens when there ends up being 2 keys for Alice? How do you choose one? That's a real big problem. That's a real big problem. If there's no trust management for keys, and I got a key for Alice, and then Trent throws in a second key for Alice, and I start saying, well, I got 2 keys for Alice. I'll use them both. You know, there goes your security, whatever. So it's not really inviting to do that if you want to keep it secure. So I don't know what this slide was about. Oh yeah, risk management. All security issues, if you aren't aware, can be boiled down to risk management. That's the way you got to look at it. Absolutely no way to be completely secure. In your car, you're driving with a seatbelt and an airbag, and now you got 4 airbags, and you got, you know, crumple zones and all this stuff. But in all reality, you're not secure. You know, you're more secure. To be really secure, you wouldn't go out in the car, right? We as a nation have chosen that, hey, it's more convenient. My quality of life is worth more being able to drive around and risk my life on a daily basis. Hey, I'm all for it. I drive everywhere. But it's a risk management game. And I think that if you already haven't, you know, learned this, think of this first from now on, because you just got to choose and say, well, is my quality of life, you know, worth more than my security? Because I can stay home and watch TiVo and never get hit by another car, statistically speaking, depending on where I live. But the point being, in security, it's exactly the same thing, right? I can spend a ton of money and make things more secure, but they can never be fully secure. I really believe that. Responsible management of email is data custodianship. This is, you know, the basics. A lot of people, a lot of companies don't even have backup for any servers, much less email. But, you know, if you want to get started on securing email, these are definite considerations. How do I keep email running? It's becoming a crucial application for my organization. How do I keep it so that I can recover from any kind of outages, backups, disasters of any kind? And then the liability management just refers to the discovery problem I discussed earlier. Key management problem. So this is what I was sort of trying to illustrate earlier. End-to-end encryption between users is the best thing, right? That's the holy grail. What I want to be able to do is send email to Alice and know that she got it. I want to know that she got exactly what I sent and not some modified version. I want her to know that it came from me. And I want to know for sure that nobody intercepted it. I mean, that's the holy grail, right? Can anybody in this room or anywhere else on the planet think of a way to do that transparently? No, we already have established that. So given that, your options are, what that means is your options are, do I want to then decide that, okay, I can't do it transparently, I'm going to have a seminar and educate all my users how to use PGP. Has anybody here tried that? Anybody tried to deploy PGP? Yeah. Had fun? Succeeded? No? Me either. I'm sad to say it, and I tried really hard. I like PGP, but couldn't make it work. So the deal is, end-to-end crypto, what I say is that it's the worst case scenario for implementation and an apocalyptic scenario for maintenance. Even if I could teach all my users to use it once, get them to start using it, over time it degrades, you know? What happens is they lose track of their keys, they lose their keys, they don't remember because it's been 2 months since they encrypted anything, they don't know how to do it anymore, and it just degrades. So I'm sad to report all these things, but I'll tell you what our solution sort of is in a moment. Trusted third party meets the man in the middle. And the reason I put this in here is that typically at Black Hat or anywhere else, you're going to see us experts get up on stage and say, well, then there's the man-in-the-middle attacks, but those are really hard, and they wave their arms and say, and they're not practical in the field, lots of arm waving. So the deal there is, I think that this is changing rapidly, right? The sophistication of attackers is getting much higher. I've seen man-in-the-middle attacks performed on SSL and SSH and PGP, and it's scary, right? I'm starting to think, wow, this is really practical. I think that, you know, the man-in-the-middle attack is what all of PKI cruxes on. All of the trust management issues that we talk about, signing keys, issuing certs, all this crap, really have to do with eliminating a class of attacks called man-in-the-middle, right? If I don't care about man-in-the-middle attacks, then I might as well throw out key management. I'm not buying anything if I don't care about man-in-the-middle attacks. Sadly, I think that man-in-the-middle attacks are becoming a bigger deal. If you look at some protocols like SSH, for example, SSH's idea of key management, they don't do any key signing, made by total paranoiacs. SSH is a great tool. But what happens when you connect to a server via SSH is I connect, the server hands me my key. My client says, I've never seen this key before. I don't know that it goes with the server. That's a really appropriate thing to do, right? And then it asks you, well, doesn't trust the key, but do you want to go anyway? And everybody says yes. You know, have you ever typed no? Everyone types yes. But the point is, yeah.
Well, I did type no, but it was fierce.
Yeah, good. Glad to hear it. Glad to hear it. I have other friends here who aren't even willing to use SSH at Black Hat. So what does that tell you? So the deal is with SSH, what is going on, this is an important thing to understand, is there is some trust management for the keys, right? Because the next time I go to that server, it's not going to give me any message. It's going to say, you already chose to trust this key. So what I have established is that the key, every time I connect to the same server, is the same, right? Over the course of a week, a month, a year. And as long as it's the same key, then I know I'm connecting to the same server or someone who's managed to go steal the key, and that's good enough, right? That's probably 90% of the value you would get out of any trust management system with keys. So my contention here is that even though SSH has simplified trust management in a sense, I think there is a good deal of value to the way that they do it. Now, it requires some user education, because if I try to connect to my mail server over SSH, and it says the key has changed, I need to get suspicious real fast, right? Because this is my mail server. It's supposed to be highly secure. I'm here telling you how secure my mail server is, right? It needs to be secure. So if I'm just saying, yeah, take new keys, no problem, then chances are that's opening to me to man-in-the-middle. So those same risks exist in SSL connections, probably even worse. I've seen that there are bugs in browsers that if you format a cert just right, the browser won't even complain about it. So it's really bad. And mail clients are even worse. Mail clients using SSL a lot of times don't even try to trust the certs. They just take anything. It's kind of sad, but it's a start. So what I'm saying is that throwing out trust management for keys makes it so that you can make email, or any kind of encryption system for that matter, seamless, transparent, painless free, all those holy grail things, easy, but of course, far less secure. Drawing the line. What I say here is that public key crypto without trust management is no better than passwords, right? If I'm going to send passwords that are encrypted, that's good enough. Because if I'm not going to manage trust on the keys, then I'm not trusting them anyway, what's the point? Then I decided, well, maybe it's about 10% better, because what you do get with keys that you don't get with passwords is you have this thing that's not really transferable on a sticky note or a phone, right? So I thought about that, and then I thought, well, maybe 5%. So now I have lots more slides than anybody else, right? Because I have, okay. Then two things I wanted to go over that I thought you guys should be aware of is the promise of cryptographic tokens. My dream for the future is that I walk up to a computer somewhere near it. I don't even want to have to plug it in. I got some Bluetooth token that says, hey, I'm Pablos. Here I am. I'm in front of the computer. Then I walk over to another computer, and it just brings up my desktop. I shouldn't have to log in. It should know it's me. I should be able to go to any computer on the planet. Why do I have to pack this laptop around? There's computers everywhere I go. But we're nowhere near that. big part of that is smart cards or smart card equivalent, right? It's a cryptographic token. The ideal here is that I have a device, I'll hold my cell phone up but pretend it's a smart card or something. I got a device that's got my public key pair on it, my private key and my public key, and it can do signing and decryption on board, right? So what it means is you hand me a signing is the same as encryption for that matter. So basically it means I can do the basic crypto operations on board. So you hand me a message, it goes into my little card or a hash of it or whatever it does. I sign it there. My key never leaves the token, right? If it never leaves the token and the token is non-forgeable, you can't copy it, then this starts to look really secure. It's like, hey, people can't put their password on a sticky because they got a token. They've only got one token. If they lose it, nobody can use it because it's activated by a PIN. You know, that's why we have two-factor tokens. Anyway, some of your companies probably have issued systems like this.
Different than like using public key. You still need to know that this token belongs to me.
Oh yeah, this doesn't solve any of those problems. That's why I say no significant improvement for trust. You're exactly right. So if you see tokens and people are saying, here's a token, it's more secure, say, well, wait a minute, what about trust management? And they say, oh, we're going to give you a cert server for that. So it's not solving these problems, right? I'm just trying to establish that these things that people are pointing at and saying, here's the holy grail of the future, it doesn't really solve all the problems. And anyway, I think there will be a space for tokens in the future. It does solve a number of problems, but they're expensive and a pain in the ass for other reasons. Promise of biometrics. This one gets even more, it's all over the news these days. You're going to love biometrics. I personally hate biometrics. I used to really like them, and I like the idea of being able to walk up to my office door like James Bond. I actually bought a retinal scanner for one of my companies, you know, so we could walk up to the door and put our eye on it, and then we looked at the retinal scanner and figured out about 7 ways to circumvent it, even though, you know, we didn't even know about retinal scanners. I don't have any direct problem with the biometric technologies themselves, although I think that they're highly over-exaggerated about the effective key space you get out of an eyeball or a fingerprint or whatever. I do feel that the main advantage of biometrics would be convenience, right? If I can use my fingerprint instead of a PIN, I'm fine with that. However, I think it's important to understand that databases of biometric data being collected by corporations or governments or anything is a really, really bad idea. We're talking about non-revocable authentication tokens here, right? There's, you know, we've been doing some research in Seattle on this stuff, trying to build little gummy thumbs and things. That's been a lot of fun. We haven't figured out the best flavor yet, but we're making gummy thumbs, and what we're trying to do is spoof the fingerprint readers at our local grocery store that you can use to pay, right? So we're out there dusting fingerprints off shopping carts and trying to make forged thumbs. And it's a really, really insecure system. It's a grocery store, right? We got, you know, we got the root password to their biometric system so we can enroll ourselves. We aren't even trying, right? We're just there enrolling, seeing how it works, and it's really, really bad. So the point is, those guys now have a database of all the other people in Seattle who shop at this grocery store and use the fingerprint system, right? I feel really, really confident that I could go get their templates and make thumbs. Yeah?
Now, of course, how often do you see checkers letting you put a gummy bear up for the
No, you don't. Yeah, you don't even have to do that. You can make overlays for your thumbs. It's pretty easy to spoof a checker, to fool a checker. I could get a job at Thriftway and make off with the computer, right? Or copy it or back it up. I could probably go in there and say, hey, I know a little about computers. I'll set up backup. You know, I would never. I honestly think that, you know, everybody, seriously, absolutely should refuse the use of biometrics in all cases until you hear otherwise from me. And the only, and since I said that, I'll tell you the one scenario that would change my mind. Is I believe that in the future I could have and there's been a few meager attempts at this, a smart card with my public key pair on it, with a thumbprint reader built into it, so that the card locally stores my thumbprint template and authenticates me to the card using biometrics, and then uses the card with public key crypto to authenticate to everything else, right? I would be happy with that. Then I own and store my own biometric template and profile information. Nobody else has that. That would be fine. That would be convenient. I'd still need a card. I couldn't go jogging to the grocery store in the nude and buy a Sobe, but you know, there's some compromises you got to make. That's, yeah. Yeah, you don't want me doing that anyway. Okay, the goal. I'm talking about what our work has been in, trying, and this sums it up, secure email for an entire organization with little or no effect on usability, right? I love to make things really secure. I fully recognize that to do that, I got to make things harder to use, and that they usually fail miserably because of that. So in our work, we've been trying to architect email solutions that are as secure as possible with no implications for the user as far as making it harder to use. And you'll be able to look at this and say, well, wait a minute, this is less secure because of all the things you already told us about. And I'm going to say, yeah. So it is less secure. And what I'm trying to do is approach this from a practical perspective and say, hey, this is something you can do in your enterprise organization, any organization, to raise the bar of security for your email right now, okay? Obviously, my company does this stuff. I don't want you to give me any work. I want you to go do it yourselves, okay? Fix your email security problems and then spread the word. So the philosophy here is, well, I put networked future. We tend to use IMAP, which stores mail on the server, caches it locally on clients, right? So with IMAP, it's a little different than POP, which downloads all your mail to your client. IMAP is nice and handy because I can walk up to multiple computers and access all my mail. My mail archive, I can have folders there and all that stuff if you're not familiar with IMAP. So network future means that we're going to assume that people are on the network. IMAP clients allow for some caching and things, so when you go on planes, you can still read all your recent mail and all that stuff. So the deal is, we're planning on being on the network to get access to our mail. Impractical is insecure, which I basically covered. We're going to make this as seamless as possible. Emphasis on standards for the reasons I talked about earlier. We don't want to box ourselves out of anything that might keep us from being as secure as possible. And keep email independent. And this is what I mentioned earlier about not having your calendaring system bound to your email. I honestly can't tell you what to do if you have that problem. I mean, there's no alternative for an Exchange server, at least that I'm aware of, other than Oracle. So in our architecture, we use highly secured email server. We've been using BSD, but you know, whatever. We like BSD because of the various security features that it has, and it's a pretty good track record, and they're pretty good about patching things. I'm real pleased with it. We're using FreeBSD, but we've also used OpenBSD. So a highly secured email server is owned and housed by the enterprise. We build this thing, or they build it, whatever. You guys could build this server. It's your mail server. It runs in your environment, right? We leverage existing protocols and mailers, which means that we go into Outlook or Mozilla or whatever mailer we're using, and we dig deep into the settings until we find the screen that says, use SSL, check. And we click the checkbox, right? So what that does is makes it so that the client, whenever it connects to the mail server, is going to do it over SSL, a well-known existing network security protocol that apparently has exploits as of 2 days ago. But no, that's only OpenSSL. So the point is, we now have an encrypted tunnel for all our messages to go over, right? From the client to the server. And this works in almost every mailer these days. It's really actually pretty cool. Almost every mail reader has a little checkbox, as hard as it may be to find, to use SSL for POP or IMAP, right? Every single one of you has absolutely no excuse not to do that. Can anybody think of a reason why they wouldn't want to check that box?
I can think of one why you can't.
One why you can't?
You have no control over your mail server.
Exactly. The only reason is your mail server doesn't support it, right? That's true of 99% or more of the mail servers. Few mail servers support SSL mode. This is what we're trying to change first. This is the absolute easiest thing. All the software is built. All your clients already support it. It works. It's pretty damn secure, especially compared to clear text. And you can do it today. All you got to do is go find the sysadmin in charge of your mail server, beat them over the head with, a copy of Red Hat 6.2 or something, and say, go check, go put a cert on the mail server, right? For POP and IMAP. This is really, really easy to do.
That will work only for small or low performance organizations. If you have a very big enterprise and have to have more servers, have redundancy built into that.
Public key crypto, yeah, what he's saying is that what he's saying is the performance issue of doing so is significant. Especially for IMAP, I think that is true. The reason being public key crypto operations are kind of slow.
Actually, for IMAP, the relative, since IMAP, the protocol itself is heavier.
Yeah. Yeah.
For IMAP, the overhead is smaller.
Well, the percentage, yeah, that's true.
It's for POP3 that the difference is more noticeable.
Yeah, okay, I buy that. I think that the deal is you are going to pay a little in performance. As far as an ISP goes, the real solution, sadly, is to go spend a few $100 on a hardware crypto accelerator. These things can do hundreds of public key operations per second. I think one of them could solve the problem for just about anybody, right? So I'm not telling you to spend any money, really, but if you're going to do it and you have that problem, I think it's easily solvable with a little bit of hardware. For a few $100 or $1,000 or whatever you got to spend on one of these things, there are a bunch of vendors. I won't recommend a vendor, but the point is you can solve that problem with a little bit of money for performance, and they work in any OS now. So I don't buy that argument. Choosing to add IMAP support where you were using POP before there is a lot of network and disk space overhead that you're going to pay to do that, right? So that's a separate issue from security, but whatever. So I do think that it's a good point to bring up. There will be a cost if you have a large enterprise. Most PCs can handle, I don't know, hundreds or thousands of users in the system without any hardware acceleration. We have lots of processing power to spare on most mail servers these days. Encrypted network protocols only. So this is POP and IMAP we've covered. The other one is sending mail, right? POP and IMAP is for receiving mail from the server. When I'm sending mail, I'm going to also encrypt it. And how I'm going to do that is I'm going to go dig through my mailer, through the preferences, until I find the box that says, use SSL for sending mail. There's a checkbox for that in most mailers too. And so what that means is it's going to use a protocol called StartTLS. And that's basically the same thing as SSL. It's just minute differences you don't even care about. Basically, it means it runs on the same port, and part of the protocol is saying I'm going to be secure. So StartTLS is real big pain in the ass to implement on some mail servers. This is something you're going to have to spend a couple days doing. I think on Exchange it actually might be a checkbox. You guys might get lucky. But for those of us in the open source mail server world, it's kind of a pain. S-Tunnel can do StartTLS now. Yes, you could use S-Tunnel, which is a wrapper that will work for POP, IMAP, or SMTP to put SSL around it. I haven't tried that. I understand that it does work. I've been told.
Actually, for POP and IMAP, all it does is it does the SSL.
Yeah.
For SMTP, it actually speaks SMTP.
Yeah.
And relays the commands to the real.
Oh, great. Okay, so they had to implement some of that. Okay, that figures. Anyway, that's a great way. Any way that you do it, and if you really get in a jam and can't figure it out, send me an email and I'll send you a solution, or some random data. Okay, and then probably the most novel thing that you're going to get from me today is per user file system encryption on the server. This is rarely done. This is something we've been really trying to work on, and we've come up with a couple ways to do it. What this means is when a message comes in from the net at large, we take it via SMTP server, and we say, okay, this message is bound for Bob. We dig up off the file system Bob's one and only public key. We encrypt the message to that and put it on disk, right? Now, this has absolutely no value for Bob as far as, that message came from Alice who's using Hotmail, right? It went over the net in the clear. This isn't really secure, but what it means is that now all the Bob's, what's that? Somebody talk to me? Jesus? What it means is all the incoming mail for Bob is now encrypted and stored on disk. This is good for a couple of reasons, right? It secures against physical seizure of the box. It secures against passive attacks where people have managed to, after the fact, get on the box. It secures against root randomly just going and reading your email or other sysadmins or whatever. So I think this is a great thing to do, right? And you know, some of our clients are like law enforcement agencies and the sort of organizations who really wouldn't want their email out there. We're also trying to make it palatable to like human rights organizations who might be running a mail server in a less secured environment. A lot of companies that I've been in, I ask them, hey, where's your server room? I want to see it. They show me where the server room is. It's behind a little lock that you could pick in 15 seconds. The mail server and all the other servers are there. How hard could it be to make off with a mail server, right? We've seen this done in real life. So the point being, we secure against physical seizure of the box. That was one of the original goals of our projects, and that's what we've come up with. And so we're working on it right now. Unfortunately, I can't give you any code yet, but I will once we're ready. That does this with PGP. So what Bob has is all of his mail is PGP encrypted on the disk, on the server, right? That's a pretty good start, I think. It's not secure against active attacks. If I can own the server, replace the SMTP server with my own code, then I can, or even just put my own keys in there and have it encrypt to me too, then I own it, or a bad guy could do that. Transparent file system encryption on the clients. This is something that I like to use, which is, I think I even have more slides on this, but the basic idea, actually I think I'm getting ahead. Let's go through. I'll get into that in a minute. Operating system security. Okay, you've learned about this in other sessions. Insecure email servers are easy to deploy. How many people have deployed a mail server in their lifetime of any kind, right? Probably, you know, within a day or so, you fire up a machine, you load an OS, you go, you know, load the mail software, put in the name of the host, couple other configuration variables, point it at a directory server wherever your user database is going to be, start adding users, and it's working. And it's like, hey, I tested it, I can send mail, I can receive mail, it's cool. That's it, right? That's a typical approach in most organizations, which of course leaves you wide open to any kind of security issue that's outside the scope of this talk. But you know, my recommendations obviously are pick an OS you can secure. I won't mention FreeBSD again, but whatever you feel comfortable with. Use the OS security features. Even people using Unix tend not to ever enable the advanced security features that are on those boxes and the hardening features, because it makes the box a pain in the ass to admin, right? But those features can save you a lot if you get owned. Can you tell me how long I have it? I'm sorry. I just want to get a rough idea. I got about 20 minutes, right? Yeah. Okay, and then be aggressive about patching. I like to say be prepared to build apps from source. Oh, I got 5 minutes? Oh, is it 5 minutes? Okay, should I start dancing now? No.
The pictures from your room,
The pictures from my room, they're coming. Hold on. It's a bunch of pasty white guys at the beach. No, so be prepared to build apps from source. I mean, I say, you know, in this day and age, being able to patch a server in real time is a big deal. That matters to me, right? In the last month or less, we've had, in the open source scene, remote root exploits for Apache, OpenSSH, Bind, and and I don't know if this is a remote root exploit yet, but as of yesterday, OpenSSL, right? Everybody running a Unix server is running one of those things. I don't know any Unix server that's not running one of those things, right? So you got to be, and that's, you know, those are publicly announced exploits. You know, now I'm getting hit by script kiddies in Romania who are just seeing if I'm vulnerable, right? That's a big threat these days. So you got to be willing and able to patch your servers and rapid turnaround, and that's expensive to do.
Or use an operating system that has the patches on the timely manner.
Oh yeah, yeah, absolutely. That's what I'm saying. That's a big help. You know, for me, it's relatively easy. Okay, great. And then used host-based intrusion detection tools. The Shmoo group makes a fabulous one called Osiris, but you could also go pay for Tripwire. Application services, I talked about those, so I'm going to skip that slide. Here's one of the cool graphics I made. Yeah, spent all night in my hotel room playing with PowerPoint, but watch, it's animated. SMTP over SSL. hey, sexy. And then it goes over the internet between mail servers, and then, Bob checks his mail. Pretty exciting, huh? I was going to elaborate on that, but, Okay, file system encryption. I got to zip through these things, I guess, but encrypted volumes are available on almost every OS. It's a good way to go, right? On Mac OS X ships with one. All the free Unix versions have, like loopback crypto and things that you can implement if you spend a couple hours learning about it, which will create a directory on your file system that's encrypted. Put your mail cache there. Put all your documents there. I can vouch for the one on Mac OS X. I can vouch for the ones on Linux. They're great.
Doesn't that make the computer not self-bootable?
No, I'm not suggesting you put everything on there. I'm saying put your data on there. So the machine boots up, then you mount your encrypted volume, and then check your mail.
That means that anytime the computer needs to boot, I need to be there.
Yes. So.
And that's undeployable in a lot of situations.
No. Oh, I'm saying, well, in Mac OS X, there's keychain, right? When you log in, it's bound to the login password, and it mounts it automatically for you, which is kind of slick. There's. Oh, for servers. No, I'm talking about for clients here. I'm sorry. I didn't differentiate. I'm sorry. For clients, I'm saying do this. For servers, yeah, which is probably what this slide is about, is TCFS is one we used on BSD and it's actively developed on Linux. We used it on BSD, and what I love about TCFS is the architecture. It does per file encryption, so the messages can be stored individually on the file system. It's unfortunately kind of an academic project that's poorly maintained. I really can't recommend that. EFS is built into Windows. I think it's sadly got the best architecture of any encrypted file system I've seen. It comes with most versions of Windows these days, Windows 2000 and I think XP Pro. It might not be in regular XP. I don't know about that. But it's real damn transparent. You got a checkbox to encrypt, and it works. And it's, I have complaints about the implementation, but I'll spare that. I think EFS it's really nice, and you should use it if you're using Windows. Use it for all your data. In vitro PGP is our name for the inbound mail disk archiving thing that I talked about, and I don't have time to elaborate on. Responding to viruses. This is a big deal for mail server operators, especially if your mail server executes code from incoming email, right? Mine doesn't, but apparently most of the mail servers on the net do.
Which?
Exchange, right?
No, mail server.
Exchange will do that.
Something people would deploy.
Oh, I'm not saying that this happens in any mail server I would deploy, but in Exchange, that's the reason the viruses propagate. A lot of them are actually propagated by the server itself. Who to blame? Some company out there wrote 95% of the code in all the viruses. Virus writers write the last 5%. So if you want to start a class action lawsuit, see me after the, no. Anyway, I actually have it pretty easy. My servers are largely immune. I have a obnoxiously large number of users who don't use Windows, which is kind of nice. And for those who do, what I do on the server is I inoculate the messages with some tools that basically look for attachments. They change the suffix of attachments so they don't auto-execute, and they look for scripts in the mail body, and they try to inoculate that by putting defanged tags around it. It's kind of annoying to get all your mail with the suffixes mangled, but that's the best we can do right now. You could go pay McAfee to solve this in a slightly more elegant manner. Encourage alternative mail clients. Personally, I prefer the mail clients that don't auto-execute the code that comes in, but whatever. I'm losing on that front. Manhandling spam. Spam, I think, is a solved problem. We created RBLs. I think that those are unfair to legitimate users. I don't like them. Per address and per message blacklists. We have a tool called Vipul's Razor. If you're not familiar with it, it comes built in with a tool called Spam Assassin that'll run, I think, on any OS. Spam Assassin is really neat. I get, personally, over 100 spam messages a day. About 3 or 4 make it to my inbox. And I'm running the default settings on Spam Assassin. Spam Assassin integrates local mail scripts, mail filtering scripts. Oh, am I at 0? It does a bunch of cool stuff. Get Spam Assassin and install it no matter who you are. It's really cool. It'll solve your spam problem. You'll love it, and it's free. User manageable, yeah, skip that. It's got a spelling error. Get the password. How to hack this system. Okay, this is actually my last slide, so I'll wrap things up. How to hack this system means I have chosen in my model to throw out key management just like everybody else, right? I take advantage of the key management built into SSL, so I'm authenticating my server before I hand it my password, and I'm hoping that my client will barf if I don't give it the right, if I don't trust the cert. But I've distilled all this down to the security available in a username and password over an encrypted connection. I think you can all do this. I think that you should all do this, and if you don't agree with me, I guess you'll have to email me because we're running out of time. I have one last thing, which is we have this big prize that we're giving away. I have to find the winner, apparently. Do we have a Brian Iori in the room? Will you come up here? You won the big prize. Excellent. This is perfect. Brian's coming up here. This is the big prize. I just have to brand it for him with his name on it here. Okay. Yeah, come on up here. Brian has won this fabulous t-shirt that says, I went to Black Hat and all they got was my lousy password. And it has his username and password on the front. I had no idea how popular the contest would be, and we have, it looks like, about 7 other lucky winners. But they don't get prizes because they weren't the first one we got. So there you have it. That's just passwords that came, people checking their mail from the session over the wireless network. They're real easy to get. I'm sure you all collected a bunch of them. Thank you very much. Feel free to bug me.